In our last video for section 9.2, we are going to go over some more simplification of rational or radical expressions or square roots. Only this time we're going to be looking at division problems, so fractions underneath the radical sign. And just how the product rule kind of helped us divide things in the last video, the quotient rule is going to help us simplify things right now with our exponents. So in our first one, a couple of things that we need to understand about the expression here, the square root of 100 divided by 36, is we could rewrite this as the square root of 100 over the square root of 36. So if that helps you kind of break it up, you are more than welcome to do that. Or you can just simplify it as is, and just remember that you're going to end up with a fraction at the end. And if you can simplify it, then simplify it. So the square root of 100 is 10. And the square root of 36 is 6. So same thing, the square root of 100 is 10. The square root of 36 is 6. Can we simplify that? Absolutely. We can divide both of those by 2. And we would get a 5 over 3. So 5 over 3. And that would be the simplest form of the square root of 100 over 36. So now let's apply that to variable terms that are underneath the radical sign. So how do we deal with that? Again, there's two ways. So when we look at this, the p to the 20th divided by p to the 10th, we remember our quotient rule and say, oh, well, we can simplify what's underneath this before we do anything else. So if you want to simplify first, that is one way to do it. So let's go ahead and do that. So p to the 20th divided by p to the 10th would just equal p to the 10th. 20 minus 10 equals 10. All right. The other way that you can write this, and we'll do that in just a minute, I'll work through it again, is to divide it up like we did here and just have the square root of p to the 20th divided by the square root of p to the 10th. And we'll see how we get the same answer as we work through it. So right now we have square root of p to the 10th. Well, again, if we want to use our little trick, we do 10, we take the exponent and divide it by the root. So 10 divided by 2 would equal p to the 5th. So when we simplify the square root of p to the 20th over p to the 10th, we're going to end up with p to the 5th. So let's come back and we'll remember p to the 5th was our answer. And this time, let's go ahead and just rewrite it as p to the 20th over p to the 10th. So I feel that the way we just did it is probably the easiest way. Go ahead and simplify first. But if your brain kind of breaks things up a little bit different, this way will work just fine as well. So we'll work through so that you can see that you'll get to the same answer. It might just take an extra step. So the square root of p to the 10th, or p to the 20th, so again, we can put our little roots in there to help us remember what we need to do. So 20 divided by 2 is going to be p to the 10. And then 10 divided by 2 is going to be p to the 5th. So rewriting it and then taking the square root gives us p to the 10th over p to the 5th. And again, using our quotient rule now, 10 minus 5 is p to the 5th. So we're getting the same answer. So in the first way we worked through it, we used the quotient rule right off the bat. Right away, we simplified what was underneath the radical sign. In the second way, we're kind of splitting up the fraction and making it two smaller radical problems, and we use the quotient rule at the very end. So either way you want to do it, if whatever seems to make the most sense to you, either way will get you to the same answer. So now we have, let's go ahead and combine those where we have whole numbers and we have variables underneath the radical sign. So now we just have all these different parts. We've got 4 different parts that we're going to be taking the square root of. And in this is a nice example because these are all nice perfect squares. So we're still going to end up with a fraction. The square root of 49 is 7, and the square root of r to the 12th, so 12 divided by 2, is going to be r to the 6th. And then looking at our bottom, the square root of 16 is 4, and the square root of r to the 6th, or 6 divided by 2, is r to the 3rd power. Can we simplify this any further? Yes, we can. So that's something that you have to remember. Simplification isn't going away. This is a concept that we've learned, and we need to watch out for it. So we always want to make sure that our fractions are in lowest terms. So when we look at this r to the 6th over r to the 3rd, we can simplify that part by using the quotient rule, correct? And again, we could have used the quotient rule here if you wanted to. I'm using it at the end, so whichever way makes the most sense. So now I have r to the 6th divided by r cubed. And remember, for our quotient rule, we subtract the exponents when the variables are the same. So 6 minus 3 is going to give us a 7 with an r to the 3rd on top. So 7r to the 3rd, because 6 minus 3 is 3. And this whole r to the 3rd just canceled out. So all we're left with is a 4 on the bottom. Now, what happens if we're combining our whole numbers and our variable terms and none of them are perfect squares and we have a fraction? So basically, we have everything going on here that we've learned in section 9.2. So we have learned that we have to break these up. We've got to break everything up and then go ahead and simplify what's under the radical sign. So in this case, I don't have my little cheat sheet over here anymore with all my perfect squares, but I know that 25 times 2 would equal 50. So let me go ahead and erase some of this so that way I have some room to work. So I'll just rewrite it over here. So 50 could equal 25 times 2. So I simplified that, pulled it apart. And then I have r to the 5th. So that would just give me times r to the 4th. So 1 plus 4 is 5. And then we're going to do the same thing with this s squared. No, s squared is fine. It's an even exponent. We can take the perfect square root of it. So there's really nothing to pull apart or simplify because we can already take the perfect square root of it. So that's everything that's on top. Now when we look at 128, that is going to be, I calculated this out, that's going to be 64. 64 and 64 is 128. So we can do 64 times 2, correct? So 64 times 2 is going to be 128. And then we have an r squared. So again, because that's an even exponent, we're just going to leave it as is because we can take the perfect square root of it. And then we have s to the 5th. So we can split that up as s times s to the 4th. So all we did was pull all the pieces apart that we needed to pull apart. And then the two pieces that were fine as is, we just left them as is. And now we're to a point where we can start pulling things out and simplifying. And again, not everything is going to be able to simplify. So when we look at our 25, we can take the perfect square root of that, and that's going to be 5. And we can take the perfect square root of r to the 4th, which is going to be r squared. And then we can take the perfect square root of s squared, which is just going to be s. All right, so we've taken care of all of our perfect squares. So we've got rid of all of those. On the bottom, we're going to have the perfect square root of 64, which is 8. And then the perfect square root of r squared, which is r. And then the perfect square root of s to the 4th, which is s squared. And then what are we going to have left underneath? So I'm going to go ahead and just put this whole fraction, and we're going to have 2r on top and 2s on the bottom. So if you want to put the if you wanted to write it like this, 2r over 2s, you could do that as well. So either way is fine. At this point, are we done? Nope, there's still simplification to do. All right, so when we look at this, there are things that can cancel out or reduce, and so we need to make sure that we do that. So let's look at, so we know that this 5 and this 8 can't reduce, so I'm kind of running out of room here. So we're just going to have the 5/8, but r squared divided by r is just going to leave us with an r on top, and then s divided by s squared is going to leave us with an s on the bottom. So we went ahead and simplified all of that. And then when we look underneath the square root of 2r and the square root of 2s, it's kind of easy to tell when you look at it in this expression right here, but these 2's are going to cancel out. So you're actually going to end up with 5r over 8s times the square root of rs. And that's how you would simplify that. So in this problem, we're using all of the different properties that we learned in chapter 6, our properties of exponents, and we're learning how to pull things apart underneath the radical sign so that we can simplify all these square root expressions.